Let's begin with a bit of background. At the end of 2025, images emerged from Shanghai showing a modest, unremarkable cargo ship sitting along the Huangpu River, near the old location of the Hudong Zhonghua shipyard. Closer inspection revealed something far more unusual. The deck was covered in shipping containers that were clearly not carrying civilian goods. They mounted naval radars, close-in weapon systems, electronic decoy launchers, and containerized vertical launch missile systems. What we were looking at was a commercial freighter rapidly converted into an improvised combatant. The most striking aspect was not just the firepower involved, but how openly visible it all was. China was not attempting to hide this capability. The ship sat in plain view, photographed and discussed online, suggesting a deliberate signal rather than an accidental leak. The earlier configuration already raised questions about China's leveraging of industrial scaling and their use of commercial hulls in naval warfare. But in early January 2026, the same vessel reappeared in a dramatically different configuration. Large sections of its missile container array had been removed. In their place sat something far more surprising: a modular electromagnetic catapult system assembled from multiple segments of truck transport. Each segment locks into the next, forming a continuous launch track whose length can presumably be adjusted depending on the aircraft being launched and the available deck space to work with. In the case of this ship, the Zhongda 79, a total of 4 trucks formed the track of this catapult. This was put in place directly onto the ship's freight deck. The overall catapult track is about the length of 4 shipping containers, or just under 50 meters long. As might be expected, given the limited size of the vessel, this is a rather short catapult. For comparison, the EMOS on the Gerald R. Ford is over 90 meters long. So the modular catapult system we see here is far smaller but far more adaptable. The Ford's catapult is of course designed to launch full-sized manned fighter jets, like the FA-18 Super Hornet. The smaller catapult on the Zhongda 79 appears to be designed only for unmanned combat aerial vehicles. We see in the image what appears to be models of Chinese collaborative combat aircraft, or combat drones, that are under development. These are almost certainly mock-ups rather than prototypes. These drones are intended to accompany manned fighter jets on combat missions and to fall under the control of fighter jets pilots. The drones are clearly intended to be stealthy, as evidenced by the counted tail fins that reduces radar signature compared to the traditional vertical tail fin. Earlier images of these drones, before they were put onto the ship, show strong evidence of navalization. They each have a catapult launch bar attached to their nose landing gear, which locks it to the platform on the back of the truck. The catapult bar, of course, shows the design is intended for catapult operations. The specific type of drone being displayed here isn't too important. There could easily have been some other drone, for example, the GJ-21 for ground attack missions. The point is that the modular electromagnetic catapult is likely designed to launch drones instead of the heavier fighter jet. In the space of just days, the freighter had been transformed from a floating missile battery into a makeshift drone carrier. This new modification is significant not because it suddenly turns a cargo ship into a true aircraft carrier. It doesn't. But because it demonstrates just how far China is willing to push modularity and improvisation in naval warfare. The key takeaway here is the speed of the modification. The cargo ship did not undergo a lengthy refit in the naval dry dock. Instead, shipping containers and modules were removed, rearranged, and replaced. The electromagnetic catapult was simply bolted onto the deck, aligned, and then presumably powered. Radar systems, communication systems, and defensive weapons were retained, while other modules were removed to make room. Just 24 out of the original 60 vertical launch cells remain, while the remainder are gone. At least one set of electronic decoy launchers and life raft capsules were also removed. These adjustments were needed to make space for the electromagnetic catapult module on the starboard side. This is of course not space efficient compared to a purpose-built warship, but it is fast, flexible, and industrially scalable. The ship functions less like a traditional warship and more like a floating chassis onto which different mission packages can be installed quickly as needed. That modularity is the real story. Shipping containers are standardized, stackable, and compatible with existing logistics infrastructure. While using containers to mount radars, weapons, and catapults is inelegant from a naval architecture perspective, it allows China to pre-build and stockpile mission modules in peacetime, then rapidly deploy them in wartime. A ship like this one, and like many other, can be an arsenal ship one week and a drone carrier the next. That kind of plug-and-play adaptability is something Western navies have talked about for decades, but struggled to implement in practice. The littoral combat ship is a case in point. The drone launch capability also tells us something important about how China may intend to use such platforms. There is no visible landing or recovery system on the ship. There are no flight decks, no arresting wires, no nets, no clear facilities for bringing the drones back on board. That strongly suggests that this is a launch-only platform. In practical terms, that means the drones are either expected to land elsewhere, such as at land bases or friendly airfields, or they are intended for one-way missions. In a conflict scenario close to China's coastline, and therefore close to Chinese air bases, or where the drone being used is considered expendable, that limitation may be entirely acceptable. A launch-only drone carrier could serve as a forward node for deploying reconnaissance drones, strike drones, or decoy drones without tying up high-value naval aviation assets. The ship itself does not need to maneuver aggressively or operate in the most contested zones. It can sit under the umbrella of friendly fighters, surface combatants, and land-based missile defenses, acting as a force multiplier. Any residual missile capacity can be used for long-range strikes, as opposed to a frontline combatant's role. In more distant waters, its lack of drone recovery capability would severely constrain its usefulness. But near China's shores or island outpost, it could still play a meaningful role. The fact that the electromagnetic catapult itself appears to be derived from a road mobile system originally seen on land is also telling. It suggests China is pursuing a common launch architecture that can operate from trucks, barges, and ships alike. That reduces development cost, simplifies training, and reinforces the idea that the platform is secondary to the payload. The ship is just one of many possible launch mediums. The drone, the catapult, and the network that connects them are what really matter. It's also worth noting that this entire sequence unfolded in full view of everybody, as a shipyard norm for some of China's most advanced naval projects, including the Type 076 amphibious assault ship, with its own built-in electromagnetic catapult. The Type 076 assault ship again primarily deploys a fixed-wing air wing of combat drones. The proximity, timing, and visibility all suggest that this was not an accidental coincidence. At minimum, Beijing appears comfortable letting the outside world draw conclusions about how quickly and creatively it can repurpose commercial vessels for military purposes. Before closing, there's a small but worthwhile correction to address from the previous video. I previously stated that the Arsenal ship version of the Zonda 79 freighter carried 48 vertical launch missile cells. That was a mistake. The correct number is 60 missile cells. My earlier assessment was based on a side-on artwork of the ship, where the horizontal viewing angle made it difficult to count the number of containers per row accurately. I now make it clear that the ship originally carried 60 VLA cells, arranged in 3 rows of 5 containers, with 4 cells per container. This correction does not change the broader argument about the ship's role or significance, but it is worth clarifying for accuracy. Ultimately, the addition of a modular electromagnetic catapult and fixed-wing drones reinforces the same underlying message as the earlier missile-armed configuration. China is experimenting openly with ways to turn commercial shipping into rapidly modified military platforms. These ships are not meant to replace destroyers or aircraft carriers. They are meant to supplement them, to add mass, flexibility, and resilience in ways that traditional naval procurement struggles to match. Whether every element of this concept is mature or fully operational is almost beside the point. What matters is that China is demonstrating a willingness to trade elegance for speed and perfection for scale. And in a future conflict defined by attrition, logistics, and industrial capacity, that trade may matter far more than you think.